Hello, my name is Güneş Gürsoy. I am graduate student at Maltepe University in Department of Computer Engineering. The presentation is about prediction of arrhythmia with machine learning algorithms. We have been having a hard time due to COVID-19 for about 2 years. Although deaths due to COVID-19 are usually in the top 5, heart diseases are at the top of the list. Among many serious diseases, cardiovascular disease is one of the most challenging diseases for the global healthcare systems, being the leading cause of death. That race related to arrhythmia and sudden cardiac death are more prevalent in diabetes mellitus patients than those of non-diabetes mellitus patients. The graphic prepared by World Health Organization. Ischemic heart disease is the top of the list and diabetes mellitus is ninth in the list. I downloaded the dataset from website of University of California Irvine. Dataset name is Complications of Myocardial Infarction, a database for testing, recognition, and prediction systems. The dataset consisting of 1,700 rows and 112 columns with the patient's age, sex, diabetes mellitus, and arrhythmia disease histories was used. 1,700 lines were converted into separate files, 70% as training set and the remaining 30% as test dataset to be used in the prediction in the MATLAB program. Existing studies show that diabetes is important in heart conditions. In the present study, gender, age, diabetes history of the patients, and the prediction of arrhythmia of the patients were emphasized. We used two methods in this study. These are k-nearest neighbor algorithm and naive Bayes classification algorithm. The KNN algorithm is used in classification problems to learn the class of data to be predicted based on previously validated dataset. A k-value is determined to predict the data class. The k-value shows the number of neighbors closest to the predicted data. Besides, a distance matrix is chosen together with the k-value. KNN algorithm uses distance matrix to calculate distance between points. First, Euclidean distance. Euclidean distance function is broadly used. It shows the closest distance between 2 points. Second distance is Manhattan distance. It is sum of the absolute values of the difference between the lines connected to points on the coordinate plane. Finally, Minkowski distance. Minkowski distance is a generalized form of Euclidean and Manhattan distance matrix. It is used for distance calculations based on n variables. Other method we use is naive Bayes classification algorithm. Bayes theorem gives the probability of an event occurring based on known event that occurred with probability. It is an effective method for many practical applications due to its simple algorithm that can make faster predictions. Firstly, we start with the predictions with Bayes theorem. In this method, age, sex, and diabetes mellitus history values of patients were used, and the answer were addressed for the arrhythmia prediction of the patients. As shown in the confusion chart, 484 patients were correctly predicted to have no arrhythmia at true class. Here, blue area shows correct predictions. According to true class, 8 patients were wrongly predicted to have an arrhythmia in the prediction made using the Bayes theorem. The accuracy rate was found as 94.72%. Other method is k-nearest neighbor algorithm. K equals 1 distance matrix are Euclidean and Minkowski. From the true class shown the confusion chart, 461 out of 492 patients were correctly predicted to have no arrhythmia. Incorrect predictions were made for 23 patients without arrhythmia and 8 patients with arrhythmia. Accordingly, the accuracy rate was found as 90.22%. Key equals 2. Distance metrics are Euclidean and Minkowski. Correct predictions were made for 449 out of 484 patients who didn't have arrhythmia at true class. Inaccurate predictions were made for 35 people without arrhythmia. Incorrect predictions were made for 8 patients with arrhythmia and accuracy rate was found as 87.87%. As shown in the confusion chart, 480 of 484 patients without arrhythmia were predicted correctly and 4 patients were incorrectly predicted. Incorrect predictions were made for 8 patients with arrhythmia and accuracy rate was found as 93.93%. In the fourth trial, as shown in the confusion chart, the predictions were correct for 476 of 484 patients without arrhythmia. For the remaining 8 patients, incorrect predictions were made. The prediction of 8 patients with arrhythmia was wrong. In the prediction, the accuracy rate was 93.15%. In the fifth experiment, the highest accuracy rate was reached with K equals 5 with the KNN algorithm. As shown in the confusion chart, correct predictions were made for 484 patients without arrhythmia from 492 patients. Incorrect predictions were made for 8 patients with arrhythmia. The accuracy rate was 94.72%. In the case of increasing the value of neighboring k in the KNN method, it is seen that the accuracy rate approaches the result obtained from naive Bayes method. Age, sex, and diabetes mellitus history values of the patients were used in the algorithms trained according to given database. 70% training dataset and 30% test dataset were used. Firstly, the accuracy rate was 94.72% in the predictions made with Bayes theorem. In the predictions made with the KNN algorithm, the accuracy rate was varied in the range of 87.87% and 94.72% depending on corresponding k values. It was shown that the accuracy rate obtained through the K equals 5 value in the KNN algorithm and Bayes theorem was the same. Thank you.